Okay, so take a look at this problem right here. Oops. Prove the identity. Cosine 6x equals 2 cosine squared 3x minus 1. Okay? So there's two ways we can approach this. The first way is to say, this is being assigned after Ms. Milkowski taught me about the double angle identities, which means I might want to try to make this cosine 6x that I see here turn into something like cosine 2 times something else, okay? So I ask you this. What if I rewrite cosine 6x as cosine of 2 times 3x? Okay? What if I rewrite 6? Do you agree that cosine of 2 times 3x is the same as cosine 6x? Yeah. Okay? Now, what if I said, okay, let's replace 3x with u, okay, to make our lives a little bit easier. So wherever we see 3x, we're going to put u instead, okay? So I could rewrite that as cosine 2u. Do you agree? Because I just replaced the 3x with u. Okay. Now, if I'm trying to get to, look at what I'm trying to get to, 2 cosine squared 3x minus 1. Okay, well, if u equals 3x, it looks like I'm on the right track because I want to get something with 3x in it. Now, let's go back to our double angle identities. So these are the notes that I did in class with you guys, okay? So look at the cosine 2u. Do you see that? Cosine 2u can equal cosine squared u minus sine squared u. It can equal 2 cosine squared u minus 1, or it can equal 1 minus 2 sine squared u. Now, the question becomes, do any of those three resemble what we're trying to get to? So let's refresh our memory with what we're trying to get to. And I see, 2 cosine squared 3x minus 1. So I'm going to flip back and look at that middle one, 2 cosine squared u minus 1. That's looking pretty good right now. So let's use that one, okay? So it's going to equal 2 cosine squared u minus 1, okay? So we can rewrite that as 2 cosine squared u minus 1. Now, let's look back up here. Do you see how I said that 3x was u? So let's substitute 3x wherever we see u, okay, because we just did a basic substitution like you guys did a lot last year. Okay, so 2 cosine squared 3x minus 1. So all we did was replace u with 3x. Look at that. And is that what we were trying to get to? It was? That's exactly what we wanted to get to. So we're done. So that was actually a really simple problem. Really simple problem. So what if we weren't sure what to do and we didn't know we should be using a double angle identity? Well, let's think about another way we can approach this. Do you agree that if I had the same problem, so I had cosine 6x equals 2 cosine squared 3x minus 1. Okay, so let's say I'm trying to prove that right there. All right, again. But instead of using a double angle identity, let's say I decide to do cosine of a sum. So I end up with something like this. Okay, so I just rewrote cosine of 6x like that, okay? All right, so now the question becomes, what do I do? So I have to remember what is the formula, or what is the identity for cosine of a sum. So that's going to be cosine 3x cosine times cosine 3x minus sine 3x times sine 3x, because remember it was cosine u times cosine v minus sine u times sine v. Okay, that was our identity. So that's all I did. I just used that identity that we're used to using. Now, do we agree that cosine of 3x times cosine of 3x can be rewritten as cosine squared 3x? And that sine 3x times sine 3x can be rewritten as sine squared 3x? Okay, so now look, I'm looking for something minus 1. And I also don't want a sine squared in there. So can I replace sine squared x using cosine somehow? And I can. We all know that sine squared x, or in this case sine squared 3x, can be rewritten as 1 minus cosine squared 3x. Okay, so all I did was replace sine squared 3x with 1 minus cosine squared 3x. Okay? Now I'm going to distribute that negative in. Okay, so take a look. I'm going to distribute the negative in. All right, and I end up with cosine squared 3x minus 1 plus cosine squared 3x. Oops. Now, do you agree? I'm having real trouble with this. Do you agree that cosine squared... Do you see how we have cosine squared 3x and we have another cosine squared 3x? So do you agree that cosine squared 3x plus cosine squared 3x is 2 cosine squared 3x? It is. So 2 cosine squared 3x, okay, because we just added that and added that, minus 1. Okay, we just added those two together. Now, is that what we wanted? Let's look. It is. Take a look at that. We're done. So I just wanted to show you that there were multiple ways to do this problem. It's okay if you didn't use the double angle identity, okay? You could have done it another way, and I think that's the most important thing for you guys to understand is there's multiple ways to do these problems. You don't have to feel like, well, I didn't see that. I don't understand how she knew to do that. It's okay because there might be another way. That'll get you to the same answer. Okay, so let's take a look at number 20 now. So it says prove the identity. Sine 3x equals sine x times 3 minus 4 sine squared x. Okay? So I'm not going to do out this entire problem. Instead, I'm just going to do the first step, and then I'm going to give you some hints that you might need to finish. So instead of sine of 3x, what if we rewrote it as sine of 2x plus x? Okay, so let this be your first step. Okay? Now, clearly you know what identity you should use after that, okay? And now I'm going to give you a couple hints for finishing it up. Let's take a look at what we're trying to prove. And remember, I always said, look at where you're going because it's going to help you figure out how to get there. Okay, so do you notice that we have a sine, oopsie, it's a sine x right here, okay? Well, chances are, if I see that there, chances are at some point I'm going to want to factor that out of some long expression, okay? And the other thing I want to point out is, okay, look how we've only got sine in there. Okay, we've got a sine x, we've got a sine squared x, okay? So chances are, if sometime throughout the process you end up with a cosine, you're going to want to change that to sine somehow, and you know a Pythagorean identity that will help you do that, okay? So those are my hints. If you still feel like you're struggling with this problem, let me know, and I'll be able to do the full thing out on the board on Monday.